Hello everyone, welcome email exercise of Principles of Compiler Design. In this video, we are going to see the topic on types of automata and finite automata. In the previous video, we have seen that what is an automata theory and what are the three basic concepts of automata theory like language, grammar and automata. Now we will see what is an automata and types of automata. So the automata, it is a mathematical machine or model or design is used to recognize the particular strings which can be derived from the particular language. So it's an abstract machine used to recognize the string of a language. So the automata, it have the three types. One is the finite automata, then Pushdown automata and Turing machine. What is a finite automata is? It is an automation with a finite number of states and no memory other than the current state. So there is a memory concept is not there in the finite automata. So we have read the string from the particular state to next state, the particular single symbol is transmitted. Next is a Pushdown automata. The Pushdown automata, it is a finite states and a stack as an additional memory. So we have a additional memory like a stack, that is a temporary memory we have in that. So the Pushdown automata is a combination of a set of states and the stack. Next is a Turing machine. So the Turing machine is an automation with infinite tape and read and write head that can be moved left and right. So it is an infinite tape. So in terms of memory, first we have a finite automata, then Pushdown automata and Turing machines. So these are all the three types of automata in the particular automata theory. Next is a finite automata. The finite automata is classified as two types. One is the deterministic finite automata and non-deterministic finite automata. So what is a deterministic finite automata? It is meant for every state, for every input, there is exactly one transition is there. So for every state and for every input, we have only one transition, is called it as a DFA. Next is an NFA, that is a non-deterministic finite automata. For a particular state, we have input symbols, but the transition that go to the multiple states. So there may be a 0, 1 or many transitions for the particular input. It's called it as a NFA. So in the DFA, for a single input from a state, we have only the single transitions, but in the NFA, from the single state, from the particular state, for a particular input, we have a multiple transition is there. That is called it as a NFA. So the hierarchy of power is like that. So DFA and NFA are less powerful than the Pushdown automata and Turing machines. So what are all the languages accepted by the automata is? So the finite automata accepted the regular language and the context-free languages is accepted by the Pushdown automata, and recursive numeric enumerable language is accepted by the Turing machine. So these are all the languages accepted by these set of automata. Next, we will see that what is a finite automata. So the finite automata contains the 5 tuples. It is a mathematical abstract model. It contains the 5 tuples like Q, summation, then transition, then Q naught and final state. So we have a Q naught. What is a Q? It is a finite set of states. Then summation is that it is a finite input alphabet. Next we have a transitions. So Q is the transition functions. Next is a Q naught is a starting state, and F is a set of accepting states. So these are all the 5 tuples of the finite automata. We have a set of states, then start state, final states and transitions, and also the set of input alphabets. So it contains the 5 tuples. Next is, for example, we have the automata that should accept the string end with 0, 1 means how do you derive the particular automata? So first we will draw and design the model for the basic acceptance of the input. So what is our basic? That automata should accept the string end with 0, 1. So we have two symbols. So the automata, the states should be the 3. So we have a 3 states like Q0, Q1 and Q2. So we have a starting state of Q0. From the state when you read the symbol 0, it goes to the state Q1. From the Q1 when you read the string 1, that go to the final state of Q2. So that is the basic. So that could be accepted, but it is not our model. That model should accept it all the strings end with a 0 and 1. So we have to extend our design like the start state la வந்து பாத்தீங்கன்னா இந்த Q0 we have the self group of 1, in Q1 we have the self group of 0, at the end we have a 0, 1. So this type of model should accept all the string end with 0, 1. Next we will have that from the transition diagram we have to construct the transition table. So the transition table, it is a rows and columns representation of the finite state machines that should contains the 3 columns like number of states, then transitions from the state 0 and state 1. For example, we have 3 states Q0, Q1, Q2. So in the transition table, the start state is a Q0 that could be represented by the arrow symbol, and the end state is Q0 that could be represented by the star. But in the transition diagram, we can represent it like the Q0 we are going to represent it, the start state is represented in the arrow mark, the end state is represented by the double circle. So this is an example of the finite automata. I hope you will understand what is an automata and what are the types of automata like finite automata, Pushdown automata and Turing machine, and what is the finite automata. It contains the 5 tables, how the automata is there, how the transition tables should be constructed from the particular automata. Thank you.